In part two of bones and bone structure, we'll take a look at the anatomy of bone tissue and the various bone cells that make up bone. So, bone tissue is actually a connective tissue. We classify it as a support connective tissue. So, I put here it's a dense supportive connective tissue. Now we're going to see that it contains specialized cells. It has four of them. We'll introduce them in a couple moments. We're going to introduce a cell called the osteogenic cell, the osteoblast, the osteocyte. Now that you may have heard of before. We typically talk about that when we talk about the tissues chapter. And we'll introduce the osteoclast. Bone tissue has a matrix that is solid. If you were to just tap on any bone, let's say you tap on the outside of your elbow and you feel your bones and that make up your elbow, those bones are solid. They also have, though, some collagen fibers. These collagen fibers, we're going to see in a moment, keep the bone flexible so our bones don't shatter. And we'll discuss that in a second. Here are some characteristics of bones that we should know already from the tissue chapter, but I'll review them real quick so that we know that bone has a dense matrix. What makes the bone dense is the deposition of various calcium salts. The cells we're going to see that maintain the bone are the osteocytes. Now, you can just call these bone cells also, but we mostly call them osteocytes. These are located in little chambers or little pockets, and these osteocytes are organized around blood vessels. We're going to see that bone is extremely vascular. Bone is a very active, dynamic tissue, so it has a really good blood supply. Our osteocytes, they can communicate with one another, and there is an exchange of nutrients, waste products, and gases through the bone. This all happens through these little narrow, small, tiny canals known as canaliculi, right? So these are just narrow passageways. I'll show you these in part three of this lesson. These are narrow passageways that run through the matrix. And again, their job is to allow for the exchange of nutrients, waste products, and gases. Like I said before, bone is a very dynamic, active tissue. One other characteristic of bone is that bone has an outer lining, a covering known as the periosteum. Peri here, this prefix means around, right, like a perimeter. And then osteo means bone, right? So it's something that we would find on the outside of the bone. If we were to dissect it, right, kind of look at it more closely, we would see that it has two components. There's an outer fibrous layer and then an inner cellular layer. We'll look at these in a little bit more detail in lesson number 3. So let's take a look at the bone matrix. Do me a favor, highlight here, bone matrix is made up of minerals, and then go down over here, it's made up of proteins, matrix proteins I put here. Also highlight, and then we'll go back and talk about it, the minerals make up 2/3 of the bone matrix, right? So the majority of the bone matrix is going to be the minerals. 1/3, if you can highlight here please, is going to be the proteins. So let's take a look at the minerals first. So like I said, guys, 2/3 of the bone matrix is made up of calcium phosphate. Now, this calcium phosphate is going to interact with another bone salt right here called calcium hydroxide. Once those two interact, they form this hardened crystal right here known as hydroxyapatite. This is what gives the bone the hardness. As the hydroxyapatite is forming, it incorporates other calcium salts such as calcium carbonate. it's going to incorporate ions, right? We put over here like magnesium. Fluoride would be another one that would be incorporated into the hydroxyapatite. So all of that makes up the hardness of the bone. Now, if you took a bone and you took away the hardness, the minerals, we would end up with a bone that looks like the bone, except it would be very flexible, right? So a bone lacking calcified matrix, it's going to look normal, but it's going to be flexible. And the reason for that is 1/3 of the bone matrix is made up of these matrix proteins, which is down over here now. The matrix proteins are actually collagen fibers. All right, so 1/3 of our bone is collagen, and that what that allows for is to give our bones a little bit of flexibility. This is an experiment you could actually do at home. It's kind of fun to do. You can take a chicken bone, put it in vinegar. Right? Vinegar is acetic acid, and the acid will dissolve the bone salts. Leave it there for a couple days, maybe like a weekend or something like that. When you take the chicken bone out, you'll see it looks the same, but when you pick it up, you can bend the chicken bone because the mineral salts are gone, and all that remains in the matrix is the collagen fibers, which allows for that flexibility. So all of this is what makes up our bone matrix. Again, the main things I want you to know, 1/3, I'm sorry, 2/3 of the bone matrix is made up of minerals. The final product is hydroxyapatite. It incorporates different bone salts and ions. And then the other 1/3 of the bone matrix is made up of collagen fibers. So let's take a look at bone cells. The bone cells only make up about 2% of the bone mass, but there's four types that we need to know. We're going to take a look at osteogenic cells, osteoblasts, osteocytes, and osteoclasts. So osteogenic cells also are called osteoprogenitor cells. Some textbooks use this term. This seems to be a newer term, but you should know both because they use them both. These are mesenchymal stem cells. So if you remember from tissues chapter, mesenchyme means embryonic connective tissue. And their job, these stem cells, is to make sure that the bone has adequate amounts of osteoblasts, which we're going to talk about next. So the stem cells make sure that we have osteoblasts. Osteoblasts, we're going to see, are important in forming new bone. Now, this is a picture from the Martini book. They did a cross section of the shaft of the bone, the diaphysis, and we find these osteogenic cells located on a lining that lines the medullary canal. This red lining right here is known as the end ostium. We also find them where the periosteum is out over here. All right, so those are the two places that we would find osteogenic cells, on the end ostium and out where the periosteum is. So here you can see it. This is the endosteum, because what they did is they kind of blew up this area right here. So we can see here's the endosteal lining. It makes up the endosteum cells. And then here's a big osteogenic cell. And like I said, this can produce osteoblasts. So that's where they're located. So think about this, especially in an adult when we're not growing anymore, we're no longer forming our bones. If we were to fracture a bone, these osteogenic bone cells are important because they can produce the osteoblasts that we need to heal our bone, to repair our bone. Right, so they are important, especially as an adult, in fracture repair. All right, so this is from the Martini book. Let's take a look at what Tortora's interpretation is. I actually like this diagram. They do a good job with this. So here, first of all, they're calling it the osteoprogenitor cell. Right, so Martini calls it osteogenic. Tortora calls it osteoprogenitor. So I'm going to have you know both names. This is what the cell looks like. Now, when it's stimulated, say from a fracture or something like that, it will now produce the next bone that we're going to look at, known as the osteoblasts. So I like this picture because it's showing the progression from one cell to the next cell. That brings us to the osteoblast. A blast cell, whenever you hear the term blast right here, means that it's an immature precursor cell. It's going to develop into a different type of cell, or it's going to change into a different type of cell. So it's an immature cell that produces the bone matrix. Here's the word you want to highlight right there. Osteoblasts produce new bone. The process of producing new bone is known as ossification or osteogenesis. I'll talk about that in part 4 of this lesson. Now, when the osteoblasts produce their matrix, the matrix doesn't come out hard. That's a process that has to take place called calcification. So the matrix that's produced that is not ossified, we have a term for that. We're going to call that the osteoid. Here's a picture from Martini. So out here is where the osteoblasts would be, right? They're going to be in the periosteum out over here. As the osteoblasts lay down new bone, they're actually going to cause the bone to become wider out over here, and the bone's going to grow in width. So what we can see, here's the osteoblast. You can see they're around the circumference of the bone. And now the picture is showing us the cells producing the matrix. The matrix, though, they painted or colored in blue to indicate that the matrix is not calcified yet. Once it calcifies, it's going to look like this. This is matrix that's already been formed and hardened. So this would be the osteoid, right? So the osteoblast produces an uncalcified matrix known as the osteoid. Eventually, the osteoblast is going to become trapped in this osteoid, which is going to harden. Then these cells are going to convert to osteocytes. That would be the mature form. Let's take a look at the Martini interpretation of this. So here's our osteoblasts. We had said previously they were formed by the osteogenic cells. Now they're osteoblasts. They produce the matrix, right? They form the matrix. Once they become trapped in that matrix, they're going to become an osteocyte, which is going to be the next cell that we're going to take a look at. And this job of the cell here, the osteocyte, we're going to see is no longer to make the matrix, but their job is going to be to maintain the matrix. All right, so here's an osteoblast right over here. You can see it's a small cell. They had to magnify this 8,000 times to see that cell. It's tiny. Once the osteoblast, again, has become the osteocyte, the cell is considered a mature bone cell that does not divide. It's just going to stay as it is. We know this already, that the osteocytes live in the small little pockets or cavities or chambers, however you want to term it, known as lacunae. Right? And those lacunae are within the matrix. The osteocyte has these, we'll take a look at it, these cytoplasmic extensions. So it's like an octopus. Here's the osteocyte, and then it has these little arms going out through it like this here. And here's another osteocyte way up in the corner here. These two will actually communicate with one another, so materials can pass back and forth through these little baby canals known as the canaliculi. The canaliculi. The major function of osteocytes is right here. A cyte cell maintains. A blast cell from the previous slide produces. A cyte cell is going to maintain. So its job is to maintain the matrix. If the bone were to become damaged, like in a fracture, and the osteocyte is removed from its lacuna, it can convert back to an osteoblast and help with repair, like fracture repair. But on a normal day-to-day basis, when the bone is healthy, the job of the osteocyte is going to be to maintain. The last thing I wanted to point out on this picture is where we find them is, notice they're not on the inner edge here. They're no longer on the outer edge here. They're trapped in the matrix. So we're always going to find the osteocytes trapped in the bone matrix. Let's take a look at Tortora. Again, I like this progression. We'll kind of review it one more time. Osteogenic cell produced the osteoblast. Osteoblast made the matrix. Once the osteoblast becomes trapped in the matrix, it became the osteocyte. And again, you can see the osteocyte is like an octopus. It has all these extensions right over here. And here's one living. Here's the lacuna. Here's the osteocyte. You can see it's a bigger cell. They only had to magnify this 4,000 times. Right? So maybe it's twice the size of this cell over here. But that's the osteocyte. Again, maintaining the bone tissue. The final cell is known as the osteoclast. Now, the job of the osteoclast is to break down bone. Right? So if you remember my example with that chicken bone, if you put it in acetic acid, that chicken bone would be dissolved by the acetic acid. It breaks down the bone salts. Take a look at this. The osteoclasts secrete acids, right? So the acids are going to break down the bone. That process is known as osteolysis. Osteo, you probably know, means bone. Lysis means to break down, right? So it breaks down bones. All right, so their job is to absorb and remove bone matrix, right? If you want to just make it in simple English here, it helps to break down bone. If we were to look at these cells, they're actually big cells that have multiple nuclei. They are not derived from other bone cells. They're actually produced by the bloodline of cells, the cells that make up blood, yeah, where the blood cells come from. For example, you'll learn this later in your anatomy physiology studies. There's two blood cells, monocytes and macrophages. These are what we call phagocytic cells. They tend to engulf things and break things down, kind of clean things up. So they're deriving the osteoclasts. So let's take a look at it. This is from the Martini book again. So we can see here, this happens to be located on the endosteum, and we'll talk about why they're there later when we talk about bone remodeling. But nonetheless, it's a big cell. Look at the size of this thing. It has multiple nuclei, and then it has these little extensions right over here. This is where the acids are going to be released. They call this the ruffled border. So that as the acids are being released from here, it's disintegrating the bone matrix over here. So why do we need to have this done? Maybe there's a time when our blood calcium levels are low for whatever reason. We need to have adequate amounts of calcium in the blood. We can break down the bone a bit to release that calcium into the blood and bring our blood calcium levels up. So you can think of the bone as a storage place, as a bank of calcium. All right, we'll talk later in, I think, the fourth lesson or third lesson, or maybe the fifth lesson, we'll talk about remodeling. Here, the osteoclasts are also important. Okay, so this is the Martini's interpretation of the osteoclast. Let's see what Tortora looks like. So notice, again, I like this picture. They put a line here to show you that this cell is not produced from these guys over here. They don't come from bone cells. They come from the bloodline. Large cell, multiple nuclei, again, ruffled border. This is where the acids are going to come out, and the job is to break down the bone. And then here's a picture of one. You can see it's a big cell. They didn't have to magnify it that much. They had to magnify it 2,700 times to see it.